So I will talk, introduce from manufacturing point of view and talk about supply chain, which is very important when we do the material because it will be used. And I will introduce simplified how we from R&D point of view, as a researcher maybe, can think about business models and that we need to do if we want to speed up the research to come to market for business. And I will give an example from this from silicon carbide because that's the topic I know best since 30 years. And this is a webinar is a part of the EU FET open project SiComb, which is about frequency comb, where you have a laser. The material can split the laser to several wavelengths, and then you can transmit much more information, much more data, and actually have much more big data increase in the data centers. So more than 100 terabit per second. So this is huge thing. So it's a revolutionary project, which now is ending in March, and it's an EU project. So that's the background why I have been active with this activity. So going back many years, if you happen to be in silicon carbide, the lower crystal here, this is from 1997, when everything was new. So silicon carbide was a lot about the material development. There were a lot of defects. No growth method was established, so you can have really reproducible and sizes are small, and then you made them bigger, and today you have 8-inch. So the nice thing is that this is a 30-year journey from the research to what is today. Now it's very interesting for the electric vehicles market, and it's a boom about that. And so it has made the 30-year journey of a material. And at that time, we were using equipment. So this is a unit, which is actually a prototype from 1997, 98 by a Swedish company. And they actually started to sell this as a SB50 sublimer. And later, this company was acquired by Axtron and so on. So this is how it can look like in a simplified environment in research. And today, you have tools which are more efficient. You can have many tools. They are close to each other. So you can have maximize your footprint in the lab. So this is actually an illustration from a Swedish company who are developing these tools. They have available. If you want to buy, you can have one or several. And it's colleagues of mine since many years who are experts in building silicon carbide tools and also the crystal growth process for the PVT, but also they are working with the other methods. And now the silicon carbide is booming. So there are many manufacturing places which are established, and the big industries are establishing in different places with many machines. But it's also interesting to do these things from our R&D point of view, because there are opportunities for the next applications. So it's not only the electric vehicles, the power conversion for that, it is also related to other topics. For example, the frequency comb for the data traffic increase. And I will show some examples later on. So it is making this change. So it is industrial. And if you can imagine in the future, we are doing the silicon carbide material, making wafers, we are making epitaxy, we're making pieces of it, we are putting the pieces of the processing into a device. The device is put into the electric car. And in the electric car, the silicon carbide is matching the battery to the engine, the battery to the infotainment, from the charging station to the battery, and so on. So that is the power conversion. So that's very nice from a conversion point of view. But actually, this is also related to data, that you can have data in between these things. And for example, to take an example, when you have the conversion close to the battery, you can monitor the temperature and monitor other things, and you can share this information to optimize things. But if you actually optimize these things in a bigger perspective, then you're sharing data and you will use this by digitalization. So this is the future positioning, how to do this more than only using it for power conversion. Uh, and from research point of view, when we are asking for money to do our exciting research to develop the new things, typically the application they are asking for which sustainable goal are you addressing? And then we look at the goals and we select one. We can take number 9, which is about innovation, industry, and infrastructure. Oh, so that's nice. Uh, so I'm an innovative guy. We have an innovative research, and we say that we will contribute to this sustainable goal. But then someone will ask, how will you do it? And this is the balance which we have to explain. So if I, as researcher, have very nice papers and we are publishing it, and people ask me, how will you take this method, the PVT, the sublimation epitaxy, which became the FSGP, the liquid phase epitaxy, how will you contribute to sustainable goal number 9? Then it will not be sufficient for us to say that we will first publish in a paper and then maybe we will make a patent. That is not sufficient today, because no entrepreneur will read this paper and they will call Mikael here, say that, I like your paper. Can I make an industry of it? Meaning that we have to be more active to bring the research findings to usefulness. And all researchers do not want to be entrepreneurs and make a startup company, but there are other ways how to do this. And that's where the sharing of data comes in. But first, let us talk about synergies. In Europe, the European Commission, they have since 10 years started an activity about regions to develop better. So this is called smart specialization strategy. So European Commission wants the regions to do better. And this happens everywhere in the world. They just have different names. They want to make more economic growth in regions. And when the regions grow, the nations will grow and the nation will bloom financially. So that's the basic plan. But they are talking about this from a regional point of view. In the European activity, they have different pillars, stuff. The first one is localization. It basically means start from what you have. If you have something good, start from that. And the second one is to actually, if you have several good things, make a choice. Choose 1, 2, 3, 4 areas and focus a little bit more on those good things. Give a priority. The third one is about make people involved, researchers, industry, the politicians. Everybody should be involved, because that's the only way how to actually make things move. So basically, the regional development activities, they try to find stakeholders, and you find areas where they're strong, and the strong areas, they will have several organizations who are active together. And at the end, this will actually be one type of supply chain or value chain. For example, from raw material manufacturing, characterization, device. That's how they can find the strong areas. You find many strong actors, and that's a strong area when there are many, and then you make something good out of it. And that's the smart specialization strategy. So actually, the regional people, they are talking about the same things that we are talking when we talk about raw materials, make it device, and when we are talking about this from research and technology point of view. So we are talking about the similar things, but in different contexts, and we are not aware of each other. So then actually, if I, as a researcher, would be more aware of the regional things, then I can say that my technology, which is part of the supply chain, it fits into the regional context. And the regional context is supported by European Commission. European Commission has a smart plan, and we fit in there. So then I can show that I am aware that this is existing. I try to support and be part of it. And now, after the beginning of the smart specialization, there comes a sustainable smart specialization strategy. So this is the next thing. And that has now changed a little bit name. But if you go to the next thing and the next thing after that, then actually at some point you will have reached one of the sustainable development goals. And you can say that, oh, I have contributed to sustainable development goal number 9 because I started being a part of my technology in the regional context and the next context, and then you come into the sustainable development goal context. So in such way, we can actually give a more realistic motivation how our things will fit into larger context. And then people will believe us. And when we apply for funding, it will give a better impression. If you compare those who only present the technology and nice research and publishing, when you compare these two applications, the one which has the better description of usefulness will get the funding. So that's part of research, but it's also in industry relevant. So basically, if we are aware more about the regional smart specialization and they are aware about our technology is existing, then we will create more impact in comparison if we would do this separately. So that's a very nice motivation, and especially from EU point of view, when they want impact, which has the most importance when they apply for projects. And simplified, if we do more things together in a more clever way, then we will actually do more things faster and get more out of it. So this is also actually usefulness for us as researcher and technology people to be part of this, because we will actually get more things done and we will actually get more money because we will be involved in other contexts. This I have seen before. So this is very attractive from funding point of view and how to be smart. And if we talk about impact factor, are we creating an impact? Are we doing something? Researchers think that, okay, I will write a paper and I will try to find a paper which has a very high impact factor, and then people will be impressed and so on. But that is not relevant as much as before, because the taxpayers will ask us, how are you making impact? We don't care about your paper. Can you show me something useful? Are you trying to do something useful with your knowledge, which has been created, to give you a salary for my tax, which I'm paying? So impact factor is also changing how we make impact. And if you compare on the left side, instead of doing things individually and thinking that, okay, I will first publish, then make a patent, and then I will make something. And when I'm finished, I will find collaboration. And if others are doing similar in their areas, of course, these things will not match when you think you are ready. So the clever way is actually to have interaction and exchange, like in the right picture, which I have tried to illustrate, to share this earlier, and then we can find ways how to actually make more realistic outcomes, and then it will be more real outcome in comparison to try to modify it later, which means that we have to exchange, interact, and we have to share information, and we have to share data. So then we're back to this thing. So with the Mats here, I have been talking about this and learning more about it because I'm a technology guy. And if a researcher do not want to do a spin-off company or be entrepreneur, then you can share the data, uh, for example, to a company. And traditionally, it has been done that you find one company and then you make an agreement, you write the MOU, and you make one-to-one business. But maybe that is not the right way to do it if you want to be efficient. So if you are creating a pool in certain area, priority area, for example, and you have several research players and several companies, the researchers can make their data available. Companies can have outcomes of the data, and this is controlled by the digitalization. Then it's a higher probability that there will be matchings of findings from the research to the company. And how to do this, because researchers do not want to share their raw data, then this is by the digitalization and blockchain, which Mats will talk about how to actually do it in practice and not give away anything. But the general context is that if we are creating these ecosystems and interactions, more things will come to use by this activity. And this we have to do because there's a climate crisis and other urgent things. So then those things are needed. And then we're back to this, what we have. We have raw material. Someone is supplying, manufacturing, distributing, customer, consumer. So it's a supply chain. And if we actually, in this whole chain, exchange data, so there's more information, then we can optimize in different ways. We can optimize so there's more technology matchings from the raw material, so it's suitable for the manufacturing. And the manufactured stuff should be distributed efficiently for a customer, so there will be no complaints. So then we're, anyway, having exchange about the information and data. But we can do this also in other ways for the business and also for the values of sustainability. When we, at the end, we will count how much CO2 has each step emitted. What's the cost? Is there a bad guy here who's emitting a lot of CO2? So the customer and final consumer, they don't want to buy this because it's some problem. And that's why we have the data for the sustainable accounting, which would be very important. And mentally, if we compare, earlier when I had one thing, I had this piece, I sold it to you. You gave me $50 for it. I went to the next guy. I sold this one, and using this one-to-one business, it's a lot of time spent for the one-to-one business. And if you compare the stock market when that one started to be really active, you can make many businesses in a shorter time period. So this we have seen. We know about the stock market. We know about the one-to-one sales. So if we compare for the future how it would look like, then from the stock market to the next things, this is what we can do with the new business models. And of course, the difference will be bigger than one-to-one to the stock market. So it will be a big transition for us, how things will change for making business and values and using digitalization. So we are only in the beginning of a big boom. And if we can be part of it with our plans, then we are actually positioning better for what we are doing. And in the industry today, when they have CO2 emissions due to some step in the industry process, you can compensate for these things using the carbon credits, which is nice, but it's not actually the perfect one. So, for example, if you would be parking your car and then you get a fine because you have not done the proper way of parking, you can pay the fine. The next day you come there, you get another fine because you're parking again, and you continue this. So this is actually not so intelligent way to do these things. So similar with the carbon credits, the right way is not to compensate after what you have done the wrong thing. Do it right from the beginning, and then you will actually don't need to pay any fine. So this is a way how to see on these carbon credit things. And then we come into the new things which Mats will talk about. How can we do accounting of the carbon? How can we do accounting of the carbon in the whole chain so everybody is aware of it? Maybe we can exchange about things. So if I have a little bit problem with my CO2, it is compensated later or before or in some way. So this is a smart way of doing the CO2 and carbon accounting. And this is now happening, and it's not established how it will be happening. But if we are part of it, we are aware that it is happening, and then we can place it in our projects. So there is actually, we can show that we are aware, or maybe we have a partner. We can invite Mats as a partner in project to be training on this, and then we can implement it. And then after 5 years, 10 years, it will be part of a supply chain or as part of a value chain. But it will come for sure, because this is a business and changing society. And when we come to next phase is what is happening. Now there is a semiconductor manufacturing. Someone is making equipment, someone is making something like that. But what is happening is that people are getting together in ecosystems and doing more things together. So a little bit similar like the smart specialization strategy. You find strong areas, you collaborate, you do more in a clever way. Also, this is an example from Finland where they have an initiative about chip zero and making a smart plan for Finland about the Finnish semiconductor industry. And they have an ecosystem. They have previously established things and built up to this stage. And what they are talking about, do not make the wrong thing. Like the CO2 footprint. This is like when you step in your garden and you step on some flowers, you're damaging the things. Then it's a footprint. And then you use carbon credit to compensate for your damage. But if we actually do like a handprint, we are doing the right things from the earlier stage. And then we can reduce the environmental impact and use resources better. So this is what this Finnish activity is talking about. And so it's very nice to see. And they are talking about the digitalization in developing smart grids, renewable technologies, and efficient practices in their area. So this is a pilot case which we can learn from and try to do something similar. And then we can do this for the future things. So then coming back to the silicon carbide, which now has gone from the research, and you have material available, and you have wafers available, larger area, cost is going down. And when the cost of the wafers are going down, you can actually propose that you can make an emerging technology using the wafers. And earlier, when we were proposing an emerging technology based on new research and innovation, people were always asking, what is the cost of this? How do you compare with silicon and these things? So then it was an unfair comparison how to motivate something early because it costs a lot when you're emerging in comparison to something which is established. But now what we can do is that the emerging technology can say now, we have the wafers, we will use them. They already have lowered the cost. We are doing some add-on to this thing. We don't need to bother about lowering the cost because the wafers make it lower cost already. So then we can tag along on the lower cost of wafers. And this was similar like silicon. In the beginning, nobody would have paid for developing silicon for the solar technologies. It was developed due to the transistors. People wanted transistor processors. The material became available. You made longer boules. You had more wafers, lower cost, and then solar application could tag along, piggyback on the lower cost of silicon wafers, and then it become relevant. And in silicon carbide, we can do something similar. For example, photonics, the frequency comb, which is our project, and then there's also quantum computing, and there are also research about silicon carbide as a light emitting material, and there is the carbon on silicon carbide, so the graphene on silicon carbide. These are like foundations for emerging technologies, and there are many other ideas. Meaning that now, when the wafers are available, this is a platform we can propose new technologies, and it will be a second wave of interesting things to happen and new business. Uh, and also the where to place the manufacturing. It doesn't need to be as before that you find areas where there's a good electricity prices or a lot of different things, which makes that in this place in Germany it's a good area because you have other semiconductors. So everybody does not need to uh, locate their new activity at these places which are established, because locally you can find that you have better electricity prices in Bulgaria, for example, and you have talented people who live in Bulgaria or close there, and they don't want to move. So instead of trying to move the talents to places, we can actually set up foundries at the places where you have talent, and also use local benefits in other ways, meaning that there are coming motivations why we can propose to have a local semiconductor foundry in some way based on some local strength. And this is similar like the place-based innovation for the smart specialization strategy. Start from what you have, what is strong, and build on that. So this will happen also for the semiconductor foundries. And I'm looking into this as a part of my activities. So if you're interested in that, I will have more information about this, but this is the first stage. And it will create new manufacturing. Silicon carbide is going from 6-inch to 8-inch to 12-inch. The ways how to manufacture this will change. The relations of supply chain and other things will make things to change. So there's a lot of new things happening, even though silicon carbide is very well established for manufacturing of silicon carbide for electric cars. So this is interesting times. And we cannot do this individually. We have to do this together. So then, in some way, whatever it is, we should form innovation ecosystems, work together, and support each other. And since we actually have internet and we can use these online platforms to meet, we don't need to move to places to collaborate. So the physical attendance is not as much needed as before. So then actually an ecosystem can create an ecosystem which is not only physically location, like science park and so on. You can actually have an ecosystem which is using the competence in other places in the world. So like new manufacturing. So with Jagdish, who's attending here, is I'm very happy to help. I sit in Sweden and I can try to support from here uh, and things like that. So this is now possible. And finishing up, when we talk about European projects, now just a week ago, there came the new strategic plan for 2025 and 2027 for the future research and innovation. And they have some strategic orientations. And of course, things should be better and more energy. But as a big part of it, there is the digital transition. So that will happen as a part of the strategic development. So if we are considering and these things already now, then we can position how we can do it and build our ecosystem so we have more expertise related to these things. And looking into the new areas where there will be money for researchers, innovative materials is one area. Silicon carbide is a nice material. Silicon carbide is using raw material, and it is green, digital transition. So that's also in line with silicon carbide. And they are also talking about making virtual worlds. So then we can actually make the digitalization, but also we can do training. And now in this part, we will not have it today, but basically, if we are making a digital twin of the whole silicon carbide, we can create training using virtual reality expertise. We can train these things before we actually do the training physically at different places. So this is also happening. So the and Nicholas Van from Vineo is expert in these things, and we will talk more about it. And there will be other meetings about these things.